If I were to ask you before this video starts, which would you rather pass near a supermassive black hole or a relatively small black hole? What answer would you give me? Write here in the comments because this will be important for the video. I'll be even more specific, either you're going to pass within 5 kilometers of the big black hole at the center of the Milky Way, which is 4 million solar masses and 5 billion kilometers in radius, or you're going to pass close to the event horizon of a black hole. Ordinary star, 8 times the mass of the Sun and only 25 kilometers in radius. It is more dangerous to pass 5 kilometers from a very large black hole or 5 kilometers from a very small black hole. This is the perfect time to write your answer in the comments. The intuitive answer is to avoid the big black hole and pass only 5 kilometers from the center of the small black hole. Congratulations, you would be dead, but in a unique way, you would have your ship, your body pulverized by a gravitational force 100 billion times more intense than the gravitational force at the Earth's surface. I know this may sound strange, but smaller black holes are the most dangerous, so subscribe to the channel, leave a like on this video because your like is very important to know if you like this type of video. So get your popcorn. That we are now ready to fall towards the black hole. Black holes are extremely simple objects, seriously. If you want to talk about a planet, you need to know its size, its chemical composition, its density. Now, for a black hole. Only one thing matters, its mass. If you know the mass of a black hole, you know almost everything there is to know about it. Black holes are the most extreme concentrations of matter in the universe. Matter is so compressed that not even light is able to escape its gravity. It is the point in space from which gravity is so intense that not even light escapes. It's known as the event horizon. The event horizon is the perfect ball of darkness around compressed matter, which is the part of the black hole that you can see and the reason why small black holes are the most dangerous. It is precisely because of the distance between the event horizon and the center of mass of the black hole. The force of gravity around a black hole depends only on two things, its mass and the distance to the object being attracted. The mass is just the black hole and the distance varies from object to object, and it is the distance that is the main factor in gravitational attraction. If a black hole doubles in size, its gravity will get twice as strong. But if you get 2 times closer to a black hole, the force it exerts on you will get 4 times stronger. That is, the force of gravity changes with the square of the distance. But we can even see that in the formula for the force of gravity. In classical physics, the force is equal to a constant times the masses. The objects divided by the distance between them squared, the distance away, the term that most affects the force of gravity and is the only term that you, inside a ship, could control in small black holes. The event horizon is much closer to the center of gravity than in supermassive black holes. Because of this, it is possible to get much closer to the mass that causes the force of gravity. Small black holes. This means that gravity is much stronger, closer to the event horizon of small black holes and more dangerous than the pull of gravity. It's the difference in the force of gravity between different parts of your ship, of your body. This difference in strength is the tidal force, which is the real danger of small black holes. If your whole body is falling into the black hole at the same rate, it's not such a big problem. Like you're going to die anyway, but at least it won't be ugly. The problem is when your legs. They start to fall faster than their torso and tidal forces separate their legs from the rest of their body. This is ugly and the tidal force depends even more. The distances than ordinary gravity are enormous near small black holes. For example, gravity near a 9 solar mass black hole is 300,000 times greater than that near a black hole. In the center of our galaxy, which has 4 million solar masses, plus the tidal forces are 200 million times more intense on the black hole. Small, so back to our example, if you chose to pass within 5 kilometers of the supermassive black hole at the center of our galaxy, you will feel your leg being pulled slightly towards the black hole, so you will continue your journey. the leg of those who chose to pass close to the small black hole will be accelerated a few million kilometers per second, faster than the rest of your body. To make this very graphic in everyone's mind, imagine that you take two ships, trap someone's body in the middle and make the two ships move away at millions of kilometers per second. Not pretty. I mean, what does this all mean? That your legs are going to be a million times heavier than I am torso. What is going to make your legs separate from the rest of your body? And the same goes for your ship and everyone inside who will be ripped apart by a force equivalent to a hydraulic press. With 6,000 T, you'd turn into a big meat spaghetti, and that's where the name spaghettification comes from, which is the name of this moral effect in the story. And to end this video, I would like to thank all of you for watching, and I hope you enjoyed the content presented. If you have any questions, suggestions or comments, please leave them in the comments below. I'll be happy to answer them. Don't forget to subscribe to the channel and turn on notifications to receive updates on new videos. Also share this video with your friends and family so we can reach more people. Finally, I would like to remind you that knowledge is something valuable and we should always be looking to learn more. I hope I have contributed in some way to your learning and personal development. Thank you very much, and until the next video.